Welcome to Get Your FRQ On. This question is from the 2000 exam. It's question 1, and it is calculator active. In the question stem, we are given a region R, which is defined as the region bounded between the following. The x-axis, not the x-axis, the y-axis, the graph of y equals e to the minus x squared, the graph of y equals 1 minus cosine x, and wherever those two graphs intersect. We are asked to find the area of the region R. Right. Now, one of the bounds of integration that we need is given in the question stem. That's 0. It's the y-axis. But the other bound of integration that we need is the intersection of these two curves, which, unless you can solve the equation e to the minus x squared equals 1 minus cosine x by hand, you're going to need your calculator to do this. The way you would do this is, in order to solve the equation e to the minus x squared equals 1 minus cosine x, graph both of those functions on your graphing calculator and then use your calculator's intersection feature to find out the x-coordinate where they intersect. And when you do that, the x-coordinate of the point of intersection is approximately 0.942, so that will be our upper bound when we integrate. All right, so the area of region R is the integral from 0 to 0.942 of our upper bound function, which is e to the minus x squared. It is above the graph of 1 minus cosine x, so that will be our big function, our top function, minus 1 minus cosine x dx. And since this is a calculator active question, we're going to have our calculator do this. The integral from 0 to 0.942 of e to the minus x squared minus 1 minus cosine x dx is approximately 0.591. In part B of the question, suppose that we revolve the region R around the x-axis, find the volume of that region. All right, so the volume of the solid of revolution can be found using definite integration. That volume is pi times the integral of from 0 to 0.942 of e to the minus x squared dx minus pi times the integral from 0 to 0.942 of 1 minus cosine x squared dx. And again, calculator active question, there's not a whole lot of point in trying to simplify this or come up with an antiderivative on your own. Use your calculator to calculate these integrals. That difference is approximately 1.747, so the volume of the solid of revolution from revolving the region R around the x-axis is 1.747. In part C, we suppose that this new solid, or the region R, is the base of a solid. The base of this solid, if we take cross sections of the base, they are squares if they are perpendicular to the x-axis, and we are to find the volume of this new solid with square cross-sectional areas based on the region R. All right, so the square cross-section of this solid at any point C will have base e to the minus c squared minus 1 minus cosine c. So that would be the length of one side of this square. So the area of that whole square would just be that thing squared. All right, so the volume of the solid defined in that manner would be the integral from 0 to 0.942 of e to the minus x squared minus 1 minus cosine x squared dx. And again, calculator active question, no point in trying to do this by hand or finding some antiderivative. Let your calculator do the computation for you. The volume of that solid would be 0.461.